Okay, let's get going. Okay, so we did already introductions. Yep. So we can just eliminate that, and I will learn how to use that better in the future. Okay, so how about example number 1? Okay, that is straightforward. Then we have example number 2 that is a little bit more sophisticated. Okay, so let's cover example number 1 very quickly, and then this guy is on canvas. Okay, so that's plan for today, and the topic is elementary motion. Okay, please familiarize yourself with the problem statement before we start our solution. And by the way, those problem statements are on canvas, so it would be pretty cool if you could like read them even before coming here. Okay, it will like save some time. So they're already on canvas, but take your time, take a minute. Alrighty, so what do we have in here? We have like initial value problem, yes? So we basically have our function a that is expressed as a function of velocity, right? And these are our initial conditions, yeah? And they ask us to determine, this is our goal, time as a function of position, yeah? And then we will just plug in here some SD, okay? That is like some number. Okay, so this is our goal. So, in my opinion, we have to just integrate, yeah? So let's do it here. Solution. So basically, we know that our A, by definition, is first time derivative of time, right? First time derivative of time. So I will just plug this one there in the very top equation. So we will basically have dv dt, and this is equal to minus k v squared. Okay, and now I was wondering before coming here. Okay, guys, you see good, yes? Even people in the last row, the font size is okay, yes? Okay, great. Okay, so what's the next step in our equation? Everything with v on one side, everything with t on the other side, yeah? So we can do basically something like that. dv divided by v squared, and this is equal to minus k dt. Okay, and I will integrate. Okay, I wanted you to be green, actually. Why you're not green? Okay, and also very important thing, integration bounds. Okay, so they told us that our velocity starts from v0, yeah, and we will end up at some v. We don't know that value, some v, okay, and that initial condition is here, yeah. We start from v0, okay, and they also told us that time we started is 0, yeah, it's here, that argument. This is time, so we're gonna start at time 0, and we will end up at some t. Okay, this integral is trivial, so if I remember correctly from school, that would be minus 1 v from v0 to v, and this is even more trivial, kt, basically, from 0 to t. Yep. Okay, so we basically have in here minus 1 v plus 1 v0, and this is equal to minus k t. Okay, let's find v. Okay, let's find v. So basically, I can write something like that, and this is equal to kt plus 1 over v0, and kt, of course, this is. And this is v0 kt v0 plus 1. Okay, let's find v. So I'm basically gonna this is a reciprocal of V. Yes, I'm just going to 3. Yeah. Yeah. I know, guys, that you all know that. I will speed up later, okay? Just this is our first discussion, yes, so I just need to find a common pace for everybody. Okay, so this is our expression for V, right? This is our expression for V. Even V as a function of time, right? Okay, but this is not what they ask us for, yes? They ask us to find something else, yeah? So I believe that we should go to the even further level, yeah? So let's jump from velocity to position, okay? So what shall I do? Anybody? Exactly, yeah. I'm going to integrate again. And the definition is, again, known by everybody, I hope, yeah? So V is first time the derivative of position. Okay, and that step is exactly the same as the previous one. So now, basically, I can take that, I can copy it. You cannot. Oh, maybe you can. I don't know. And instead of V, I'm gonna put in here ds dt, right? I'm going to repeat myself. Now everything with s on one side, everything with t on the other side. So what do we have in here? So we are going to have basically ds, and this is basically v0 k v0 t plus 1 ds. Integrate again. Okay, and can anybody help me? What integration bounds I should plug in here in those two integrals? Yes, thank you. Yeah, it's similar step to the previous one. Yeah, just let's look at the top equation. Oh, you raise your hand, sir? Yeah. No. Okay, sorry.
On the right side, or on the right, but mine. 0 and t.
0 and t, yes.
And, 0.
Perfecto. Okay. Now let's integrate. So basically, let's go here. So what do we have in here? We have s, and this is equal to, I believe, that would be. Oh, this is not true. Oh no, it is true. V0, kV0, logarithm natural of our of the thing from the denominator, yeah. This one. And of course, you said that from 0 to t. Yep. So we will end up. So I believe I can get rid of this thing. S is equal to 1k, 1 over k, log natural 1. And that would be, and that's it, yeah? Yeah. Okay, so we basically found S as a function of time, right? But again, is this what they ask us for? No, because if we like scroll up the board, they ask us to find the opposite function, yes? So they don't want us to find S as a function of time. They just would like us to find T as a function of S. Yeah? So unfortunately, guys, a little bit more algebra, yeah? But I bet that you all know how to do it, so I can probably be even silent right now. I can just write on the board. So what do we have in here? Great. We have t as a function of s. And for the final question, is this what they ask? Is this what they asked us for? Sir, who is nodding? No, but don't worry about it, because they ask us to find not the entire function, you know? They just ask us to find it for the certain value. You know, so basically, you know what it is, yeah? Yeah. Perfect. Yeah, exactly. So I can basically copy paste. I can copy paste this one, and I can add this subscript there. SD. So it will not be S, but it will be SD. And this is the end of the problem. Okay, guys, that's the end. So our like not like t, but it's like a t star, let's say. Yeah, this is like a fixed value. Okay, and now time for questions. Are there questions? How was it, guys? How does it look like from your perspective? Do you like it more? Yeah. Usually people ask me, in the past I remember somebody asked me, what is SD? Yeah, SD is like, I don't know, 4 meters or like 4 feet. Yeah, it's like a number. Okay. I don't remember any other question. Yeah. Okay, are we good? Second example. Okay, let's do it. So again, please familiarize yourself with the problem statement before we start our solution. Okay, let's do it. We can do it. Okay, this problem is trickier than the previous one. We will see why. Okay, we will see why. I will get there. Okay, so what do we have in here? We have our point. So our point is basically following this trajectory, right? We have a basically point going this way. Yeah, and you can see that that circle is our trajectory. And they told us to tell them everything about that point at this location, right? So they told us to find, so our x at position minus 20 feet can be here or here. Yeah, but they also specified that y is larger than 0. Yeah, so I can get rid of this guy. Yeah, so this is basically where our point is. This is exactly where our point is. Yeah. Oh, and I'm missing one information, but you have it on that nicer picture. Yeah. So I believe that on that picture they showed that the velocity of that point is this direction. Yeah. Okay, guys, this is like first time from 2.5 semesters I'm teaching in person. That's why I sometimes forget things, okay? Because number, name, last name. Like number like 1, 2, 3, 4, 5, okay? Just attendance. Yeah, name and last name. Okay. Pardon me. Okay. So let's find position. Let's find position at that point. Yeah. So position is basically x, y, z. Yeah, x, y, and z. And they basically we have for free two numbers, -20 and 0, and y we will, and basically they told us that y is equal to this. Yeah, r squared minus x squared. Plug in values. 25 squared minus 20 squared. If I remember correctly from primary school, 15, yeah? Okay, 33% of the problem done. We have our position. This is our vector, yeah? It's exactly this vector, by the way. Okay, questions? Velocity. So now let's find velocity. Okay. We can also, maybe before writing down velocity, just I want to write maybe that vector in this form. So r is basically x, r squared minus x squared, and 0. Okay, so basically by definition, our velocity is d dt of r. So in other words, d dt of that guy I just wrote there, okay? Zero. So basically I can enter with our derivative inside the vector. So in order to find our components, we have to do d dt of x, d dt of r squared minus x squared, and this is done. We have this for free. Okay, so let's start maybe from beginning. Why not? Let's find this component. Okay, and guys, can anybody tell me what is this? dx dt. How much is that? Anybody? This is yeah, first time derivative of the x component of position. Yeah. So yes.
Letter next to like the x, r squared minus x squared. Up top.
So this?
No. Right up in the corner. That. What is that equal to?
This.
Yeah.
R.
Okay.
Small r. Yeah. Yeah. Okay, guys. So what is dx over dt? Somebody wanna give it a shot? Yeah. Okay. No, I do mind, but this is for the first time in the history that you gave correct answer by not saying anything, because we don't know. Usually what I heard in past, and think that if you had it in mind, people usually say 1. Is it 1? No, it's not. Or one time person said 0. It's not. The correct answer is that we don't know. Nice, thank you for that. Gentleman in the blue shirt, yes. We don't know. So let's call it x dot, okay? So basically, you can either write dx dt or x dot, okay? I just want to save my ink. So I'm not going to write dx dt, x dot is the same, okay? We don't know that value. We don't know that value. Actually, that function even. No, that value, that's that value. Why? Because x is not given to us explicitly. Do you remember previous problem where we had like explicit functions? Yeah. In here we don't know. Okay. So now, just in case you guys are thinking, why is it not 1? So what is this? dt of dt. This is 1. Or what is dx by dx? What is this derivative? 1, yeah. But this is not 1. This is x dot. Okay, so we don't know what that is. So let's move forward. Maybe we'll figure it out later, okay? So let's do, now let's do second component, okay? Of velocity. So not this one, but the second one, okay? So now we are going to do dy over dt, dy dt. And this is basically d dt of this square root, okay? R squared minus x squared. Okay, we have still 20 minutes, I believe. This is enough time to solve that entire problem. Okay, so I don't know, do you want me to ask you what that is? Or, yeah, I don't know. Okay, okay, I want to ask you, actually. I want to ask you. Anybody want to help me? If not, it's fine. So I'm going to start. 1 over 2 r squared minus x squared times what? No. No. R is constant. R is constant. I heard correct answer somewhere from there, and it was a lady's voice. Okay, that's it? There's something here still. dt. dxdt, exactly, yes. Because we differentiate over dt, yeah? Check out the board, yeah? We differentiate over the left side, yeah? Yeah, so it must be dx dt. However, I told you guys that I'm going to save my ink, okay? So instead of that, x dot. Okay, yeah, this is our thing. So it's minus x dot r squared minus x squared. Yeah. Am I scary, guys, or something? Why you are not participating? Yeah. I'm here, actually, I forgot to say during the introduction that I am very pro student, actually. I hope you can see that, yeah. But, you know, I mean, why not? Yeah. I'm very pro, yeah, just, I'm here to help you, yeah, just participate if you want to. If you don't want to, it's fine. Okay, so our velocity vector looks like that right now, yeah? X dot, yeah, thank you, sir. Okay, so look, guys, we know everything besides x dot, yeah? So this is our unknown. This thing and also this thing is unknown. Yeah, it's only one unknown. So if we find x dot, we basically have our velocity vector. Yes? If you don't mind, I would like to ask you for help for the third time. How can I find x dot? In other words, what information they gave us in the problem statement we could use right here in order to find x dot? Anybody? Perfect. And what about it? Constant. And it is equal to 120. Let's do that. Perfect. What's your name? Jason. Jason, okay. Great. Okay, so let's do that. So basically, our speed, which is basically absolute value of that vector, yeah, this is equal to, if I remember correctly, squared plus x squared, x dot squared, r squared minus x square root, yeah? And this is 120. 120. Okay, so again, this is like one equation and one unknown, yeah? One equation, one unknown. Solvable, yeah, we know how to solve it. You guys solved such equations, I don't know, 700 times in your life, yes? So, do I want to show you steps, how to do it? Maybe I can, why not? Let me see. Okay, so basically, we can end up with something like that. So next step would be basically velocity is equal to x dot absolute value 1 plus x squared r squared minus x squared. Okay, and our x, and this thing is basically this divided by that. Plug in values. Yeah, I did that problem yesterday at home, okay? So you guys can plug in values, you can grab your calculators, and you can see that our x dot is equal to 72 feet per second. And if I remember correctly from school, this is either equal to 72 or this is equal to minus 72. So we ended up with two values. One is correct, the other one is incorrect. Which one do you think is correct? Positive or negative? Positive. Look, do you remember that I forgot about that vector? And I said that it's important, yes? That vector will give you the answer. Yeah, that vector points out kind of to the left, yeah? So which one is correct? Positive or negative? Perfect. Negative is correct. Yeah, my explanation was fine? Did you get it? Yeah. So this one is not physical. This is not physical. Okay, so one more time. X dot is minus 72 feet per second, by the way, because this guy points towards left, just in case you were not looking at the board. This guy points to the downwards and to the left. That's why X dot is negative, okay? Okay, so I think that like 2 minutes ago I said that once we have X dot, we have the entire velocity, yeah? So basically plug this value here, guys. Plug this value here. And you will obtain that our velocity vector is equal to minus 72. And this is 96 and 0. Plug in values. Feet per second, of course, yes? Nice. Answer. Okay, guys, we have still like 13 minutes. So far, so good? Or do you have any questions to what's going on? Yeah. Do you like the style of the discussion? Yeah. I hope it's not like too... Okay, that was my next question, actually. Is it too slow or is it too fast? I can slow down a little bit, no worries. Okay. So, and by the way, if you have questions, put your hand up, yeah, or just, yeah. Okay, 66% of the problem done, yes, because we have position, we have velocity, acceleration right now, yes? Let's do it. acceleration. So basically, our acceleration is equal to x double dot, y double dot, and z double dot. Yes. However, this is a planar motion, so it would be 0. Okay. So basically, we must find x double dot and y double dot, and if we do it correctly, we can call it a day. Okay. So let's do it. And that was tricky. Actually, yesterday I spent some time on that problem. So let me just refresh my memory, okay? Because I did like 2 tricks in there just to make the problem easier, okay? Aha, okay. Trick number 1, okay? Trick number 1. I just would like to take this expression, guys. I just would like to take this expression, okay? This one. Okay, and we will simplify it tremendously, okay? So I just would like to have x that is equal to minus v, yeah? Remember, our x that was negative. 1 plus x squared, r squared minus x squared. Okay, and I would like to simplify this denominator. I would like to simplify this guy. Okay, so what I would like to do, I would like to do, so I can basically express this one as r squared minus x squared divided by, maybe, you know what, let's do it. If I do something, I should do it correctly, yes? So I believe that this expression can be simplified to this form. Because I can express this one in a smart way, yeah? I can express it as r squared minus x squared divided by r squared minus x squared. Yeah, I can always do it. This is 1, so it simplifies our problem tremendously. Okay, and you can see, guys, that we can cancel out this thing, this and that, and this is equal to r divided by r squared minus x squared. And by the way, this is y. The thing in the denominator is y. If you look at the problem statement, this will be y. Okay. So now let's go back to our first line. So I can basically write in here minus v divided by r y. Yep. And this is constant, by the way. That factor is constant. So in order to obtain x double dot, I can just do simple differentiation. So that means that x double dot is minus vr y dot. Yes? Did you like the trick? It simplifies the work tremendously, yes? And by the way, we know everything because we know what v is. If I remember correctly, it was 120, r was 25, and y dot we obtained here. It was 96. So plug in values, minus 120, 25 times 96. Grab your calculators and you will obtain that our x double dot is 460.8 feet second square. Great. Okay. Okay, so one last thing and we can go home, yes? So how did I find y? So now this value, yeah? So how did I find it yesterday? Because I also remember that I did a trick in there. This thing. So y double dot. Okay, which expression would I like to take right now? I know. So now I just would like to remind you guys, look at your notes here. We obtained that, oh, here. We obtained that y dot is equal to minus x dot. And this is the same thing. That's the same square root, yeah? So instead of that square root, I will just write y. Okay, because this is y, basically. This is y. That's square. So basically, I'm gonna write y in here, and we obtain, I don't know, quite beautiful symmetric equation, I would say. Beauty is subjective, yes? Yeah. Okay, so I just would like to take this expression that we obtained from this line, yeah? And I believe that it's very easy to find y double dot from that expression, okay? So I'm just gonna copy it. Oh. I'm gonna copy this guy here. I hope I can. Okay, and I just would like to differentiate it once, okay, over time. dt. And I believe that, do you mind if I ask you for help one more time? This is final time today, okay? So can anybody do this for me? The left-hand side. Just the left-hand side. With factor, yes, y double dot y plus y dot squared. Yeah, and your name? John. So John, I'm not going to ask you for the right-hand side because the answer is exactly the same. Yes, instead of yeah, because it's symmetric. Minus x double dot x minus x dot squared. Okay, and this is again one equation and one unknown because we guys know everything in this, every single value in this equation besides one, just this one. Okay, we calculated everything else earlier today. So this will be y double dot, I believe that was like 15 plus 96 square, yeah. This is minus 460.8 times minus 20, and that was, if I remember correctly, minus 72. Yeah. Okay. As you can see, just one letter and all the numbers. Yes. So for the final time, grab your calculators and obtain that y double dot is equal to. Oh, that's pretty cool. 3, 4, 5, 6. 3, 4, 5, 6 with a dot in here. Feet per second square. Okay. So that's it. We found our acceleration. So that would be minus 3, 4, 5, 6. Yeah. Okay. So that's the end of the problem. I'm looking forward to your questions. But after my last comment, we did today 2 problems, yes? First one, easy. That one, kind of sketchy, yeah? Kind of more sophisticated. Why? Because in the first one, those expressions, the A, the D, or position, they were given explicitly to us, yes? In here, they are not. They're just telling like, please read the problem statement one more time, or even compare those 2 problem statements with one another, yes? And basically, if we are not given, so my point is that if we are not given those expressions, at least one of them, explicitly, it will be longer, basically. It will be longer problem. Okay, that's my take-home message. Are there questions? Okay, I hope to see you again on Friday.